Hello dear students, in this video I am going to briefly explain what the Pythagorean theorem is, or Pythagoras theorem. You can actually call it by any of those two names. And it's basically explained with this little diagram and this formula that you can see here. Okay, let's remember one important thing, and it is that the Pythagorean theorem only works with right triangles, which means that they are triangles that include 190-degree angle in them. Okay, so you cannot apply this with a triangle like this. Sorry, that actually looks a triangle like this or like this, because they are not right. So this is the Pythagorean theorem. Okay, this relationship that we have over here. So we called the two legs of the right triangle A and B, and the hypotenuse, which is the longest side opposite to the right angle, is called C. And the Pythagorean theorem says that if you have the length of the side of one of the legs to the power 2 or squared, plus the other length of the side squared, is equal to the hypotenuse length squared. Or in other words, that if you were to build a square on this part and a square on this part, and you combined both of these areas, you will also get exactly the same area that the square that you can build on this part. Okay, sorry, yeah, more or less. Okay, this is square. Okay, but let's actually see this in action, and let me show you how we can use this knowledge in order to find missing lengths of sides of right triangles. Okay, and we have this little drawing of right triangle, which legs measure 3 and 4. So this is the hypotenuse, and we don't know the hypotenuse. But let's remember the Pythagorean theorem. A squared plus b squared equals c squared. Okay, remember A and B are the legs. Okay, so that means that okay, one little important thing. It doesn't matter in which order we name the two legs. Yes, I can say that this is A and B, or that this is A and this is B, and it will not actually affect the result. So let's say that 3 is A and 4 is B. Well, so for this specific triangle, the Pythagorean theorem will be 3 squared plus 4 squared equals c squared. Okay, okay, but we called the hypotenuse x, so let's actually call it with that letter, x squared. Okay, what is 3 squared? 3 squared is 3 times 3, and 4 squared is 4 times 4. It will be x squared. 3 times 3 is 9, 4 times 4 is 16, and 9 plus 16 is 25. Okay, so 25 is x squared. Okay, but that doesn't mean that the length of this side that I am like overlining here is 25. No, because 25 is x squared, not x. We actually need to find x. Okay, so that is why we will need to do the opposite operation of an exponent here. Yes, and in this case, since we have exponent 2, we are going to have a square root on the other side. Okay, and in order to find this square root, we only need to find a number that multiplied by itself is 25. Okay, so more or less like this. Square root of 25 is a number, and that number multiplied by itself is 25. And by experience, you know that this number is 5. Yes, because 5 times 5 equals to 25. Okay, so, sorry. In this specific case, the length of the hypotenuse is 5. But let's do it in a case in which we have the length of the hypotenuse in one of the legs, and we don't have the length of the other leg. Okay, in this case we are going to also call it x. So let's remember the Pythagorean theorem. A squared plus b squared is c squared. And remember, a and b are the legs, so a and b are x and 5, or 5 and x, it doesn't matter. And c is 13. Yes, so let's write the Pythagorean theorem for this case. It will be that 5 squared plus x squared, remember the two legs, equals to 13 squared, the hypotenuse square. So remember, 5 squared is 5 times 5. X squared is, let's leave it like that for now. And 13 squared is 13 times 13. So 5 times 5 is 25. 13 times 13 is 169. Okay? Let's get rid of this 25. Yes, because we want to have the x alone. So this is positive. Here is the positive. So let's move it to the other side, subtracting. So it's x squared equals to 169 minus 25. Yes, so 169 minus 25 is 145. Sorry, 144. And in order to have x, we need to find the square root of 144. Yes, and remember, square root of 144 is a number, and that number multiplied by itself should give you 144. And in this case, we know that it's 12. Yes, you can easily find it by testing with the first few numbers that you know until you find that it's 12. But you may say, or you may ask yourselves, what happens when the number is too big, or we can't actually find the exact value of the square root of something? Well, in the next example, I'll show you what happens. So here, we have this right triangle. 4 and 6 are the legs. The hypotenuse, let's call it also x, or let's call it actually y. Yeah, let's call it y. So remember the Pythagorean theorem. A squared plus b squared equals c squared, and a and b are the legs. So for this case, it will be 4 squared plus 6 squared equals to y squared. Well, 4 squared is 4 times 4, which is 16. B squared is 6 times 6, which is 36. And y squared, we still don't know it. So 16 plus 36, it is 52. So 52 is y squared. Okay? And in order to find what is y, we need to find the square root of 52. Yeah? And remember once again, square root of 52 is a number, and that number multiplied by itself is 52. Okay? So let's try to test it. 1 times 1, it is not. 2 is not. 3, 4, 5, 6, it's not. Because, 6 times 6 is 36. 7 times 7 is 49, it's not. And 8 times 8, it's not, it's 64. So we already passed the number that we wanted, no? Because remember, 7 squared is 49, 8 squared is 64, and we actually have no trace of where the square root of what the square root of 52 is, no? Because it should be in between 7 and 8, so it will be 7 point something, okay? 7 followed by 13 decimals that we don't know, okay? For these cases, we always use calculator, okay? Let me show you. Sorry, where's the calculator? Yeah, so let's say that you want the square root of, sorry, 52. Square root of that is 7.21111025550, and okay, whatever these decimals, and probably there are more after these. So for those cases, you will be actually able to use calculator. Um, there are methods, sorry, that you can use in order to find the square roots by hand, but they are really complicated and they are not often taught in school. So that's one of the many reasons that you can have calculator sometimes in math class. Um, but don't worry, because at the beginning you will most likely find exercises that have natural square roots.